All right. So this document should be on Canvas on course page, and there are a bunch of questions here which cover the unit of light and everything about light. For example, what happens when light hits the mirror surface, and what happens when it interacts with something as such as glass or water. And that is the case of refraction. When it hits the mirror, it's case of reflection. And it is also true that when refraction happens, reflection is also possible, and things like that. We will eventually get to all that, but I'm going to start with question number one, which is very simple, and it asks you, what is the primary reason for what is the primary reason shadows form and when light is blocked? Okay, so the first four questions are about the size of the shadow and what happens when you've got something that is blocking the shadow and things like that. So question number one is about, okay, so when light is blocked, what happens? What is the primary reason? Primary reason is that light travels in straight lines and it cannot pass through the object. Okay, so that's how the shadows are formed. So if you have a light source, let's say right here, and actually make let's make Alright, that's the light source and this is the object. Okay. So the thing is, light is beaming out everywhere and in a straight line, right? And let's say this is where the screen is. Then what you will see is this part of the light is blocked, but this part not. So on the screen, what you will see is that this will be shadow, while this will not. Okay. So the reason that this happens is that the light travels in straight lines. If light could do something like bend like this, then you will be able to have light part on the screen, or I should say, you will be able to have nothing on the screen, no shadow. Okay, but the light travels in straight lines, so that's why it's not possible. Question number two is what happens to shadow when you move an object closer to the light source? Well, as you can see here in this side diagram, if you bring something closer, same size, it's gonna now block more of the light. Okay, that means the shadow is gonna be bigger. So if you bring something that can block the light closer to the source of the light, it blocks even more of the light. So it creates a bigger shadow on the screen. And also, I mean, so the option number two is correct. The shadow becomes larger and less defined. And in part number one, answer is option number C. Question number three is what kind of shadow will a small point light source create? All right, for a small point, right? Let's say this is the light source. Let's say this is the ray. This is another one. This is another one. Another one. Another one. Another one. Another one. And this is the object. Okay. So imagine a ray that just like is just right next to where the object is, and then this one on this side. Okay, so all the rays here are blocked, and that is what gives you shadow on the screen. Okay, that's shadow. Okay, so as you can see, a a small point. Oops, April Fool. There's a. Do you guys see that? You guys can't see that. There was a goose running on my screen. So when the shadow is really sharp when you have a point source. Okay. How does the size? Question number three is, oh, that's the goose. Question number three: what kind of shadow will a small point light source create? It's gonna create a sharp and well-defined shadow. Question number 4 is, how does the size of light source affect the sharpness of the shadow? So let's consider a case when instead of a point source, you have mm, a source that is not point. So that is like an extended, like a big bulb, okay? Now you have an object, let's say here, okay? That's an object, okay? And to the right, you've got screen, like so. So let's see what happens. So light ray from here, this part, let me make the object smaller so that I can actually have it projected on the screen over there. Alright, that's your source, and that's your object. And on the right hand side, you've got the screen. So what happens is, the ray from this point, let's say here, ray point is from this point, it's the screen here. So this part of the source creates a shadow here. Okay. Now imagine what happens when ray from here comes and hits this over here, and then it hits this screen over here. So this creates a little shadow here. Okay. But in this case, I just took 2 points, like here and here. But there are a bunch of points all on the boundary of the object. So what you will see is that the shadow, because of the size, is going to be the darkest at the center, but not so dark on the outside. Okay? So the actual shadow will be dark in the center and not so dark on the outside. So if you look through the option, then it should say, first of all, not a sharper shadow, so a blurry one, right? And that is the right answer, a smaller light source. No, not a smaller light source, sorry. We're talking about size of the light source with the sharpness. So if the light source is large, then it is blurry. So the option number C is correct, which says a larger light source creates a more diffused or blurry shadow as compared to, in this case, a very defined shadow when the light source is point. Okay, so that's the difference between the two. Question number 5, again about shadow formation. So question number 5 is, a small light source is above a table as shown below. Draw lines to represent light ray to show where a shadow is formed. Label the parts that are bright and dark. Okay, so again, remember, light is beaming outwards in every direction. But when it comes to shadow, we only care about the rays which almost do not hit the object. So those will be this one and then this one. Everything here will be perfectly light up, okay, but not this region. This is where the shadow will be. Okay. So the question says, label the parts that are bright and dark. So you know that this part over here will be shadowy or dark part, and this will be light, and this will be light. Right, now we have two sources. So usually what happens is, look, here the shadow was pretty much well defined because there was this one source. But when you have two sources, it is possible that shadow that is formed by one source is, I should say, light from first source can fall onto the region where it is shadow because of the second source. So that region is like dark plus light, so it becomes kind of less dark, or I should say not very dark. So that's what happens. So that's how you get shadows which are fuzzy and not sharp. So question number 6 is about that. Question number 6 says, two small light sources above a table as shown below. Draw lines to represent light rays to show where a shadow will be formed. Label the parts that are bright, dark, and fuzzy. Okay, so from the first light bulb, the first light bulb, alright, this is where the shadow is. Oh, not that. Shadow. Let me call that shadow 1 from light bulb 1. From light bulb 2, this is shadow 2. So as you can see, what's happening is from light bulb 1, from light bulb 1, the shadow because of 2, so this part over here, that is the shadow because of 2, is illuminated a little bit. Wait, I should be very careful here. So you see the shadow because of 1 is here, the shadow because of 2 is here. So the overlapping region is this, where it is shadow from both the sources. Okay, so let's make sure we actually understand the overlapped region. So it's like dark and dark, so it's going to be intense dark here, clearly intense dark or really dark. Okay, but here in this region you've got shadow because of 2 but light because of 1, so it's going to be less dark. Here you've got shadow because of 1 but not shadow because of 2, so it's going to be less dark. So this is the region of less dark, and this is the region of less dark. It's like excuse me, it's like mixing colors, you know. If you have a black paint and then you mix more black in it, it's going to be probably more black, or even if not more black, it will be equally black, right? But if you put a little bit of light color in it, let's say white, then it will be gray in color, right? So what's happening is that region where shadow because of 1 and shadow because of 2, they overlap, the shadow overall becomes more dark. Okay, but where on the right hand side there's shadow 1 but there's no shadow because of 2, so what's happening is the light from 2 is able to illuminate a little bit of the region in shadow 1, so it kind of becomes gray or less dark. On the left hand side, the light from 2, sorry, light from 1 is able to illuminate part of the shadow from source 2. So that's why you have less dark. So you have less dark, those two sides. And in the middle region, you've got really dark. Question number 7 is create a diagram. So this was about everything between question number 1 to 6 was about how shadows are formed and what happens when you have multiple sources of light, and then what happens to shadow because of that. Question number 7 is create a diagram illustrating the reflection of a light ray from a plane mirror. Label the following components: incident ray, reflected ray, normal line, angle of incidence, and angle of reflection. This is perfect. This is perfect. This is perfect exercise to learn and to actually see for yourself how reflection works. So always remember, whenever you're working with mirror or even with like glass or refraction stuff, make sure the very first thing you do is make a normal line. So a normal line is a line that is perpendicular or 90-degree to the mirror surface or to the glass and air interface. Okay, so let me make the normal line with yellow pen. All right, now what I'm gonna do is I'm gonna do it doesn't tell me what angle to choose, so I'm going to just choose 45 degrees. Okay, so this will be the angle of incidence. Okay? Remember, what is the angle of incidence? This is, okay, not any other angle. So this is incidence, and this is where the incident ray is traveling. The reflected ray, as you should say, also makes 45-degree angle. Reflected, reflected, 45 degrees, and this is 45 degrees. Yeah. So it says incident ray, so that's incident ray. Normal line, that's normal line. Angle of incidence marked, angle of reflection marked, and then this is the reflected ray. Remember, very first step should always be to make that normal line, or to make that line which is hypothetical. So you will not see normal line in real life. It is just because we define these angles, the angle of incidence and angle of reflection, to be with respect to this normal line. So that's the reason that we have normal line in the first place. This normal line is a hypothetical line. It's for us to understand law of reflection. Okay, you will not see this line in practice, but you will definitely see incident ray and reflected ray. So we established a law of reflection in class. What does this law state? The law of reflection is incident angle is equal to reflected angle. Right? Angle of reflection is same as angle of incidence. A ray of light strikes a mirror perpendicular to normal. What is the angle of reflection? Well, if it is perpendicular to normal, then the angle of incidence is 0 degrees. And then from the law of reflection, we know that the angle of reflection is also 0 degrees. So that's your answer. A man stands 2 meters away from a plane mirror. How far is it from the man to his image? Well, in a plane mirror, what happens is, however distance you're far away from the mirror, your image is that much distance behind the mirror. So if you're standing 2 meters away from a plane mirror, that means the image is 2 meters behind the mirror. So if the question is how far is the distance of the image from the man, it's going to be 2 meters from the man to mirror, and then mirror to the image is going to be 2 more meters. So the answer will be 4 meters. Okay. If the question was what is the distance of the image behind the mirror, then the answer would be 2 meters. But the question is how far is the man to his image? So it's going to be 2 from man to mirror, and then from mirror to image 2 more. So that's why total 4 meters. Question number 11 is an object 2 centimeters placed 5 centimeters from a mirror. How far and how tall is the image? So remember, however much you are away from the mirror, your image is the same amount behind the mirror. So that's why 5 centimeters from a plane mirror, that means the image from the mirror will also be 5 centimeters. And also the size is the same. So if the object is 2 centimeters, then the image size is also 2 centimeters. So 2 centimeter tall and 5 centimeter behind the mirror. All right. So question number 12 is a boy stands at the side of a girl in front of a large plane mirror. They are both at the same distance from the mirror as shown in the diagram below. Which letter represents where the boy sees the image of the girl and why? Okay, so this is what happens. Girl is right here. Okay, this is where the girl is, right? This is where the girl is. Now, girl's image is going to be the same distance that the girl is from the mirror, but behind the mirror. So definitely girl's image is at A. So the question is, which letter represents where the boy sees the image of the girl and why? Well, the answer is A. The answer is A because that's where the image of the girl is. But if you really want to like answer why, and if you really want to make sure that you get full credit for this question, I would like you to do something like this. So make a make a normal line, and I'm going to show you what I'm going to do with it. That's a normal line, and then the angle of incident is same as the angle of reflection. So the way we see anything is because light falls on that thing and it is reflected from that thing into our eyes. So if the girl is to be seen by the boy, the girl will reflect off the light on the mirror and into the boy's eyes in order to be visible to him. So once you do this, you can retract the reflected ray and it retracts to point A. So that is why the girl's image is seen at point A by the boy. So, but do not get confused between A and C here. There was a similar question in activity packet, one of the activity packets in this unit, and someone asked me why C is not an answer. C would be an answer if the question was something like where I should say where in the mirror you see the girl's object, the girl's image. So where in the mirror you see it at point C. But the image itself is behind the mirror. Okay? And how much behind? At point A. Right? That's the question. That's the answer. Question number 13 has to do with, again, the law of reflection. So question number 13 is, light incident on a plane mirror makes an angle of 30 degrees with the mirror surface. What is the angle of reflection? Well, if it is, oh, so it's a tricky one. So the thing is, this is normal, right? So the angle of incidence is same as angle of reflection. But if this is 30 degrees, then this is 60 degrees. The reason is that this total is 90 degrees. So if this is 30, you take 30 out of 90, that gives you this angle to be 60 degrees. And that is the angle of incidence. So remember, that's why we need that normal line so that we can safely, accurately calculate, measure the angle of incidence and angle of reflection. So this is the angle of incidence, which is 60 degrees. That means the angle of reflection is also going to be 60 degrees. Oh, yes. All right. Question number 14. A frog in an enclosure is eagerly eyeing a fly in the adjacent cage, using a mirror to help it. Where are the images of the frog and fly located in relation to the mirror? If the frog can see the fly can also see the frog. True? Use a ruler to draw lines that show how the frog and fly can see each other. Well, this is the scenario, okay? There's a wall, and then that wall is going to be the limiting factor on the region on which this fly is visible to the frog. And specifically, this question is asking us to use a ruler to draw lines that show how the frog and fly can see each other. Well, okay, we just have to draw a bunch of lines. So remember, let me just make sure so what I'm going to do is I'm going to draw a bunch of lines coming out of the fly because it's like these lines represent the reflected light from the fly and they're gonna hit the mirror and reflect off of the mirror, and that is how the frog will be able to see the fly. Okay, so it can happen if, let's say, this is the normal. So one light ray comes in, hits this, makes an equal, and go to the right, gets into the eyes of the frog. What if other light ray hits here? I think then it's also visible. What about here? I'll say also visible. Okay. So that's how you draw a bunch of lines. You just make sure these lines they follow the angle, the law of reflection, and you will see that there will be a region in which these lines, when reflected off of the mirror, are able to enter the frog's eye. That's it. Question number 15 is consider a light bulb and plane shown as a plane mirror as shown below. There are many positions where you can stand to see the image of the light bulb. Instead of illustrating all possible positions, we will focus on the two light rays from the bulb that strike the edges of the mirror and reflect. These represent the incident rays hitting the mirror surface. The long red dashed line represents the normal line which is drawn perpendicular to the surface of the mirror. All angles are measured with respect to the normal line. After determining the angle of incidence, find the corresponding angle of reflection and use a ruler to draw the path of each reflected light ray. The region between the two reflected will represent all positions if you stand on the ray. Remember, the reflected light must obey the law of reflection. Where is the image of the bulb located? Okay. So what we're going to do is that we're going to do two things. We are going to find where the image of the light bulb is, and the second one, where what is that region in which this image is visible. Okay, so let's do the light ray on the left. The light ray on the left makes close to, like, that is 65. That means that is 65. That means this angle, I should say, this angle is 90 minus 65, which is 25 degrees. 25 degrees. I want to make sure that this is also 25. You will see that this is close to 25. So if this is 25, let me just not use that ruler. If this is 25, then I think this is the angle. That's going to be 25 as well. Okay. Let me just freehand draw this. Alright. So if this is, let me actually also do this. So whatever this angle is, which should be close to 22. If this is 22, then this is 78. Okay. So if that is 78, then something like this is also 78. Alright. So the next thing you do is you retrace these reflected rays. So you just make them backwards. Yeah. And then this one over here. And then pretty sure it needs to be bigger than that. But use your protractor to get the image. I'm gonna cheat a little bit. Okay. So what you will see is that this is where the image will be. Okay. And then this image will be visible in this region. Okay. That's how you get the region of visibility and also where the image will be. Question number 17 is, what happens when the bulb is moved to the center of the mirror as shown below? Follow the same process and then once again where the image is. So remember, image is going to be just behind the mirror and at the same distance at where the object is from the mirror. So that's why the image is going to be here. And there's a second way you can actually do that, and then that's what I did. The incident ray here makes some angle, right? I made sure that the reflected ray also makes the same angle, and then I retraced it to the back of the mirror here. I did the same thing on the incident ray to the right. And then when the retraced ray, the second retraced ray meets the first retraced ray at this point, that's where the image is. And you will see, and you can go ahead and measure that this distance is same as this distance. So really, I didn't have to do all that. I could have just made the image right behind the plane mirror at the same distance as the object is from the mirror, right in front of it. We're not going to do question number 18 because it talks about the speed of the light in different medium, which we never discussed. Question number 19 is the bending of the light as it appears from one medium to another medium is called refraction. That's the whole point with refraction. I think we're going to talk more about it, but if it's like air to water, you will see that the light bends in the water, right? That changes direction. That's what a refraction is. Just like reflection, we also establish a rule of refraction. What is it? Well, the rule is if the light is coming in from a less dense medium to a more dense medium, let's say from air to water, then the light changes direction so that it gets closer to the normal line. And when the opposite is happening, let's say light coming out of water into air, it gets away. Okay, so that's what we learned. That's the whole thing. Now, question number 21 is when the light is incident on glass of a container of water, we can observe both reflection and refraction. Identify what is wrong with each of the drawings below when light travels from air into water. Well, this is what's wrong with in the first figure. Well, what's happening is, as it says right here, the light is traveling from air into water. So there's a change of medium from a less dense medium to a more dense medium. That means the refracted ray should have bent, should have changed the direction, which is not happening here. So that's what's incorrect here. No direction change of refracted ray. Alright, for the second one, what's wrong is this is the incident ray and then this is the incident angle. That means the reflected angle should also be the same, but it looks like it's smaller. So that's what's wrong. Incident angle is not equal to reflected angle. Question number 2 and 22 is the same thing. What is wrong about this? Okay. What's wrong about this is the light ray in water is the incident ray, that is the incident angle. So the reflection angle again should be something like that. But it's not, it's this, which is more than that. So incident angle is not equal to reflected angle. Question number 23 is a fish is swimming in a calm, clear pond, and a bird is flying over the pond. Draw some lines that show how the fish can see the bird. From the point of view of the fish, in what direction does the bird seem to be? Draw in the path that light takes. Okay, so this is a clear example of when you see something underwater, it's not really there. In the class, we saw I was able to show some people. I had this cube, a plastic cube, and I put marble in it. When you look from top down, it looks like it is raised slightly. Okay, but it clearly is not sitting on the floor, but it looks like the floor is raised a little bit. So this is a classic example here where this bird over here is trying to get to this fish. And if the bird is smart, it'll know that the fish where it looks to the bird is not there. And we will exactly see how that works out. So what's going to happen is I'm going to make these bunch of normal lines. Okay. And these normal lines actually show me the points where I'm going to demonstrate this happen. So if the light is traveling from a more dense medium such as water into air, okay, it bends away, right? So then this right here will bend away, right? But this right here, the angle of incidence is zero, the angle of reflection is also zero. So what the bird is gonna see is where these two lines they converge. Okay, so you just retrace this line over here, and then this line over there. At this point is where the image of the fish will be. Okay. So clear example of how that happens, how something that's in the water looks at different place than where it actually is. All right. So these are the questions, and that's the goose, the Fool's goose. And these are the questions that are in the practice problem set, and the level of the questions in the exam will be approximately the same. It will be objective question based, which means it will be multiple choice based, so that like you should definitely prepare for that. So keeping in mind that it's going to be multiple choice questions. So you can see some questions like this, like the first 3 or 4 questions were all objective based here and things like that. So yeah,